cloner.
Motherfucker, do you speak it?
Yes, I do, and so shall you. Let's go. Okay, I think we're ready to start. So here I have 10 layers representing different techniques, tips, tricks that I really like and I use daily. And I figured it might be useful for you as well. So some of them you might be using already. So just check the description area down below, see the whole list of whole 10 things that I'm going to mention here. They're all timestamped. If you see anything or something that is interesting for you, click on that timestamp, check it out, and hopefully that will make your day easier using clones. So let's start. First one, combine geometry. So if you want to use cloner or clones as a mesh for particle emission, you will notice that if you connect the shape 3D or 3D object that is connected to the cloner system directly to the particle system as a emitter, there is only one mesh emitting and the cloner system is completely disregarded. So particle system is thinking about this shape 3D as if it's just connected to the root and is in the center of the graph. Now in this case, that's not what we want. So in order for us to send the whole cloner system to the particle system as a mesh emitter, we need to consolidate and combine all of this geometry. And there's a note for that. It's called combine geometry. So as soon as you connect that to the root, pipe in the geometry that you want to treat, so in this case this shape 3D, it becomes a part of the combined geometry node. So basically all the clones that are spawning here now are consolidated as one mesh in this node. So I'm just connecting the shape 3D to the first input, which is called geometry source. Now I can grab this geometry source and pipe it into the mesh emitter of particles. And if I restart the playhead, all of a sudden all cloner system is working as a mesh emitter for particles. This is not restricted to just cloners or just particles. This node, combined geometry, actually works with any and all geometry that you import. So basically if you have several meshes and you want to treat them as one, send it to fields, particles, clones, you name it. This is exactly how you go about it. This node combines different meshes. Okay, let's move on. Number 2. Cloner's effector control via Null. So this is extremely handy if you want to animate multiple things with just one slider or one handle, or you want to make an interactive setup. So if you are using cloners, you might have noticed that all of the effectors has parenting available. It's not necessarily needed if you want to make those effectors run with the cloner, but they're there. So what's their purpose? Well, basically you can grab all the effectors that you want connected to one controller. I'm connecting it to this null, for instance, and then control their positional values via this null. So I'm going to unhook this math modifier. And when I'm changing the values in the null, as you see, it's changing the values in both effectors. So basically both effectors are now controlled via this null. I find this extremely handy. I use this in majority of my rigs if I'm working with clones. So I'm going to set this back to the 0 state, and I will plug back this math modifier, and I'm going to mention that not only you can control the effectors via this null, obviously this is a null, so you can rig up and connect all the other things that you want. In this case, I added a little ring that kind of showcases where our FallOff exists, just for the showcase purposes. So if you ever wondered why does an effector have a parenting property, this is exactly why. Right, let's move on. Number 3, cloners effectors procedural FallOff. So there are many options in the effectors for FallOff. So you can go for infinite, linear, sphere, procedural, or box. But then at some point you might notice that neither linear, spherical, or box setting really facilitates your needs. Maybe you have a specific shape that you want to use as a FallOff, let's say a pyramid, or some kind of a custom mesh that you imported from another package. Well, that's exactly where the procedural FallOff comes extremely handy. So in order to take advantage of the procedural FallOff, all you have to do is add a procedural root and then one of the two nodes, either 3D primitive, as I did here, or a 3D object. That is if you're using a custom 3D model that you brought in from another package. So let's get back to the 3D primitive. The only thing that I changed in this 3D primitive is the primitive type. So instead of the default box, I went for the pyramid. And that's literally the only change that I made on the procedural side of this setup. So all the custom settings comes through the Effectors FallOff bracket. So let's set this up together. I'm grabbing a plain effector. I will connect this to the first input of the cloner, the effectors. And now I'm going to grab this procedural root and pipe it to the first input, procedural FallOff. Cool. So this is set up. Now I can alter some settings. First of all, I'm going to address the behavior. So I want things to become smaller as they exceed the FallOff space. I'm going to set the uniform scale, -1. Invert this FallOff, choose the procedural property. And now it's just about setting up the correct inner FallOff and FallOff power for me to get the results that I'm seeking. There, I think this kind of works. I think you get the gist of the technique. This is literally as easy as that. So with this procedural FallOff, not only you can take advantage of the 3D primitives that are available via procedural system, you can bring in your own meshes and use that as a FallOff, or you can build something really crazy via the very procedural system and pipe that in. I'm trying to call out every single change that I made in the scene related to the specific nodes that we are talking about, but if I happen to forget one or the other setting that I've changed, bear in mind that Notch helps us here. Anything that is set to a custom setting and out of the default is marked a little bit brighter in the node. So once you're checking this file, if you have it downloaded, notice that the properties that I've altered, they're all marked up a little bit brighter. With that said, let's move on to number 4. Select child as child for cloners. So probably we are all familiar by now with the fact that Notch cloner can output 3D data, but it doesn't have to be directly connected to the cloner. So if you want to make your setup a little bit more complex or dynamic, you can always use something like nulls or select child nodes to achieve that. So in this case, this is exactly what's going on. So let's focus first on this part here. Why am I using a null to output these shape 3Ds set to toruses? Well, notice what happens if I connect all of these 3 toruses directly to the cloner. It completely changes the look because cloner is thinking that every single torus here is a different operator. Now in this case, I don't want them to be different operators. I want to treat them as one operator. So in order to do that, all I have to do is connect a null and then parent all of these 3 toruses via this null. So all of a sudden, cloner is thinking that this is one operator that he should be thinking of. Now, if we move on a little bit further, you will notice that there's 2 select child nodes. So we'll stop this animation for you to see better what's going on. Basically, we have a select child node with 2 operators, and with the mat modifier set to square, shooting information 0 or 1, we're saying output the 0, which is this shape, or output 1, which is this shape. Same thing is happening here. All of a sudden we have much more interesting scene because we have dynamic objects as operators. This is obviously a very simple example, but I'm sure you're going to find a space for this technique in your complex rigs. So let's move on to number 5, clone everything, even particle systems. So cloner clones 3D geometry, and if your particles are expressed as 3D geometry, you might as well clone them. This is exactly what's going on here. So if I unhook this null from the cloner and connect it to the root, you will notice that this is just a little particle system that has a tiniest bit of the turbulence going on and is being expressed as a clone to particles for the spheres and as a geometry connection renderer for the triangulations and lines. Since geometry connection renderer is based on 3D and we are outputting the spheres via clone to particles as a 3D, we can actually send this whole thing to cloner, and that's exactly what we're doing here. So I'm connecting all of the system via null to the cloner as a radial setup. Now, as mentioned in the previous example, it's important to make sure that the cloner understands that this all setup is one operator. That is exactly why I put everything under one null. This is just a good practice in general because it makes things a little bit more tidy. Plus, if you're using nulls in between geometry points, you actually build little systems that moves the whole rig, whatever the rig that might be. Okay, number 6. Random cloner for landscapes and effector-based Cull rig. I am sure that throughout the span of your career, you had an art director or a customer coming to you saying, I need a forest setting. Please deliver a cityscape. Make me a landscape. And that is a valid request. And I'm certain that to deliver this brief, you would use something like a cloner. However, if you use regular cloner, you need to stack a lot of effectors to build that random or versatile environment. Well, you don't really have to do that. There's already a node called random cloner. As soon as you plug this node up, you have all the randomization controls directly in the cloner. Let's say scale randomness, spread, spread heading, pitch, bank, you name it. Now in this case, since I'm building a forest, I don't need any pitch or bank settings. I literally need them to be flush and 0. The only thing that I want to change is the spread heading. So now they're all rotated in different directions. And of course, I want them to be in a different scale. One thing that is important to remember when you're building landscapes, cityscapes, or a forest with this kind of a technique is to set up your pivot point or a 0 point in the bottom of the node. So in this case, this tree has its control point in the very bottom, in the base of it. If your mesh is set to the base as your control point, you can do spawn or growth animations. In this case, all we have to do is change the clone scale. And as you see, it looks as if they are growing. Now, mind you, this is not a very complex animation, but sometimes this is all that you need for them to literally pop in. And the only reason why they're popping in so flush and nice is because they're set on the floor as a start point. So let's talk about the second part of this tip, trick, technique. Let's address the Effector-based Cull rig. So here you are, you deliver the landscape, cityscape, or a forest to your customer. And the customer comes back and says, brilliant, this is lovely. Now all I need is a street crossing this forest, this landscape, or this cityscape exactly there, exactly in this direction, in this angle. Well, it's actually easy to set up if you use something like a plane effector. So if you grab a plane effector, set it to a box setting, and set the scale to -1. Mind you, you have to remember to tick on uniform scale, so all 3 properties, X, Y, Z, scales together. You just build a custom Cull box. And to ease your life further, you can use Null to control its position. Now, if you have a Null connected to the plane effector's position, there is no reason why you couldn't add extra elements to it. So for instance, a pavement, a car, or even a guy leaning on it. And since you have all of this rig connected via Null, the repositioning or rotation of this setup is just as easy as changing one property. Moving on, number 7. Let's check it out. Here we have clone to image fake depth image. So cool thing about a clone to image setup is the fact that you can offset clones by brightness. Not only you can offset clones by brightness, you can actually make clones bigger as they go further from the initial axis. So all of a sudden you can build something like a fake depth image. As you see, as I'm moving around my hands, this setting is offsetting all of those clones in accordance to the motion. And in this case, the key element here is not the settings in the clone to image node, but 2 post effects that are applied on the video signal going to clone to image node. And that's the frame difference and frame feedback. So let's talk a little bit about the signal that is coming into clone to image. Let's preview it. So here you vaguely see the interpretation of the video signal that is being piped in. So what's going on here? So let's start with the frame difference. Frame difference grabs the previous frame and the current frame, blends them together, and where it sees the overlap, it emits something of a likeness to a luminance. I'm making absolutely zero justice to this node when I'm talking about it technically. If you actually want to read up about the technical properties of this node, don't forget that you can click on the question mark on any and all nodes available in Notch, and you will be brought to a manual page with a proper description of what does this node do, how does it work, and best practices while using it. So as mentioned before, in this setting, clones are being offset by brightness, and the brightness appears only when there's motion on the screen. So as I'm moving around, these are the bright spots, that's exactly where the clones would be offset. So let's check it out. This is havoc, this is crazy. It's crazy because we're missing one more element, and that's frame feedback. So frame feedback smooths the signal that is going out. So just check this out. This is no frame feedback, and this is with frame feedback. All of a sudden, it's much more smooth and much more flush. So with those 2 nodes plugged in to the source of the clone to image, all of the properties that you might alter in the progression, like clone offset by brightness, clone scale by brightness, are interpreted much smoother. And all of a sudden, with just a regular camera, you have somewhat of a depth image that you can use for some interactive, fun setups. Okay, I think we're ready for point number 8 in this list. So let's check it out. Cloner effectors with text. I cannot stress enough how versatile are the cloner's effectors. Basically, not only it works with the cloners and you can do a lot of crazy things with it, it actually works with several other systems like text and deformers. We're going to cover deformers next, but let's talk about text now. So you have a text node available in Notch, and as soon as you bring in any typography, any font to the resources, you will be able to use that font, that typography, to express and write any text you want. Notch understands Unicode too, so it shouldn't be an issue with any language, with any sign that is out there in the world. So, as you may have noticed, text node usually has quite a few inputs here in the bottom, and the very first one is Effectors. Very same Effectors from the cloner system. So here I have several plugged in. So it's a plain Effector, and as you see it's moving left to right. There's a randomize Effector, and there's a turbulence Effector. And all of them are connected via Null, just like in one of the first samples, and they're animated by this math modifier, shooting this 0, 1 setting, moving the Effectors from left to the center. So in this case, Effectors is just an awesome tool if you want to make your text dynamic. Animate in, out, go left, right, you name it. You can do, well, practically anything you want with Effectors when it's being used with the text. Next point, number 9, clone Effectors with deformers. So this is where things become even more interesting. This is really applicable if you're doing some kind of a product presentation, for instance. You have a car vendor or car maker who says like, I need an interactive setting where my car just disperses and we show the engine, or we show a specific part of the interior, and I want people to swipe their hand over the sensor and it should be just dispersing or coming back together. This is super easy to set up if you're using Chunk Effector Deformer, and Chunk Effector Deformer works again with the very same Effectors from clones. So this kind of a setup requires a little bit extra preparation of the 3D model before it comes to Notch. I'm going to show you exactly what I did with this car model before I imported it to the resources. So I will open up Cinema 4D because that's the software that I use for modeling. I will grab this 3D model, bring it in. I'll start with wiping off all of these textures. I don't really need them now. And I will talk about the one and only thing you need to change if you want to chunk up the model in Notch. And that is to make sure that all the separate 3D elements that are available here in this model are connected as one 3D mesh that we can chunk up in Notch. That's pretty easy here in Cinema. So all I have to do is just click and choose all of the 3D geometry, right click and go connect objects and delete. There we go. Now I have literally just one 3D model of this car with all of the 3D elements contained inside. So although this is one mesh, the polygon groups are still preserved. That means that I can use a Chunk Effector Deformer with all of the Effectors from Cloner, with all of their FallOffs, to disperse this model back and forward with the chunks and polygon groups that are still preserved, even though this model is set as one. I will delete this floor, and I can just save it as a model that I want to bring into Notch. So I'll call it car. And since Notch reads Cinema 4D files natively, this is all that you have to do. Now, in case you're using any other package like Maya, 3ds Max, Blender, or any other package, likely the procedure of consolidating all of the meshes to one is rather similar, and all you have to do is just save it off as object or obj file. There is one gotcha though when it comes to obj files. Make sure to tick on property called export object as groups, as this is the very property that allows you to take advantage of those mesh groups that are all confined in that one model. So I'm ticking it on, I'm pressing OK, and just to prove a point, I'm gonna bring it in. So let's call this new layer a car. Let's grab the car model that we just made. Let's maybe make it bigger. Let's set it to 10. I'll pull it to the node graph. I'm gonna make sure that we see things better by enabling the grid. Let's make the car bigger. And now let's grab a Chunk Effector Deformer. Let's connect it to the car. In the Chunk Effector Deformer, we always should set the vertex source mode to chunks. And now we can grab a plane effector connected to the first input of the Chunk Effector Deformer. And we can do all the crazy that we want with this effector and any other effector that you might choose to connect to your imported 3D model. So back to the cloner effectors with deformers, the point number 9. This is pretty much it. Again, we're using a null to control several effectors at once as they're moving around with their FallOffs. Now, obviously, this is a very high level overview of all of these features that I'm mentioning. If you are new to Notch and you find some of these things that I'm talking about a little bit unfamiliar, be sure to check out notch.1/learn section, link below in the description. Take the essential course and take the intermediate course. This will give you perfect 101 knowledge of all these things that I'm talking about, and then all of these little techniques that I'm showing will make more sense to you. Some of them are already listed there. Some of them are already being shown from 0 to 100% state, literally in the course. So do check it out. It's a very good place to learn a little bit more about every single system in Notch, and of course the clones. And if you're not into e-learning at all and your preferred learning platform is YouTube, do check out Notch VFX YouTube channel. Again, link in the description. There are a ton of great tutorials when it comes to cloners and everything else. In fact, there is a whole stream dedicated just for clones where all the major techniques and all the major tricks are being covered. All right, so with that said, I think we're good to move on to the number 10, clone the clones. As stated before, since cloners actually works with geometry, the clones are the geometry. So if you want to clone a cloner, that's absolutely fine. Actually, there is no limit on how many iterations of clones do you want to clone. It's literally up to you and your GPU. So in this case, this is just a little demo of a cloner set to the radial setting, cloning this clone to mesh based 3D object. So let me just make sure that you see this 3D model a little bit better. So first of all, this is a 3D scene or a 3D model with full bone structure. And it's being piped to the clone to mesh. So all of a sudden we're applying clones on top of this mesh. And the clone that we're applying is these spheres. And it has a little randomized effector just so that the spheres would be a little bit more random in scale. I've gotten this mesh from mixamo.com. That is a great resource. It's owned by Adobe, but all of the products there is completely free of charge. So there's a ton of characters, there's a ton of animations to pair with those characters, and you can download them. Not only you can download the ones that are available here, you can just upload yours in a static T position in an OBJ or FBX format, and you can rig up the bone structure. It's going to take 2 minutes, and you have a custom 3D model all rigged with bones, and it's going to be recognized in Notch. So this is exactly what I'm using in this setup. So not only I'm cloning the spheres on the mesh, I'm actually cloning the very mesh via cloner in a radial setting. And we have 20 iterations of it. And this radial clone has a little bit of animation with the sine effector, so these little fellas looks a little bit different in scale, just for dynamics. So that concludes the list of 10 things I wanted to show to you about the clones. I hope you found something interesting here and something useful. If you have any questions, please leave a comment. I'm happy to answer. Otherwise, do check out the Notch VFX YouTube channel. Crazy amount of good tutorials there. Or jump on e-learning available via notch.1/learn section. So with that said, see you next time and thank you for watching.